My chapter 5 question says to calculate delta H for the reaction given, which is for ammonia plus 5 oxygen gas, will yield 4 nitric oxide gas plus 6 water gas molecules. And then we are given the following information. So to find this equation, or to find delta H, we need to rearrange these to make this equation. So we look at the first equation and we see if there's anything in common with the final equation. So we see an oxygen on the reactant side and an oxygen on the reactant side. We see nitric oxide on the product, and we see nitric oxide on the product, so that's good. We don't need to flip anything, but we do notice that there's a 5 and a 4 here, and since you can multiply this by 2 and get 4, we'll just multiply this first equation by 4 and the delta H, because we're given the delta H's. So if you multiply this equation and the delta H by 2, you get 2N2 plus 2O2 will yield 4NO, and then if you multiply the delta H by 2, you get this. And then we do the same thing for the next equation, see if there's anything in common, and we see there's an NH3 here on the product side, but there's an NH3 on the reactant side. So we know we need to flip this equation, and we also know there's a 2, we see that there's a 2 right here and a 4 right there, so we need to multiply this by 2. So you flip it and you multiply it by 2, and then you do the same thing for the delta H. And so once you flip it, you get 4NH3 will yield 2N2 plus 6H2 gas. And if we flip the equation, we also have to flip the sign of the delta H, so that no longer is a negative, it's a positive, and then you multiply it by 2. You do the same thing for the last equation, so we see if there's anything in common, and we see there's an oxygen on the reactant on both equations, and water on the products for both equations. So we see that there is 6 H2O's, and there's only 2 here, so and there's a 5 right there, but it'd be easier to multiply this whole equation by 3, and we don't need to flip anything. So if we multiply that whole equation and the delta H by 3, we get 6H2 plus 3O2 will yield 6H2O. And then we can cross out anything that's on the products and the reactant side, so that would get rid of the 2 N2's from the product reactant and the 6 H2's, and then you just add everything else. So you get 4NH3 plus 5O2, and then 4NO plus 6H2O, which is this up here, and then you add all the delta H's, and that gives you this number. But since we don't want joules, we want kilojoules, you divide by 1,000 and you get your final answer.